survived so admirably last week, we have a few more goodies for you this evening. We want to first recapitulate one point which we emphasized rather strongly last week, and that is this concept that any number of separate parts, when brought together, create a new unity. And explore a little further the thinking of Pythagoras on this subject and possible applications in modern philosophy and in modern living. We decided that if we took 6 little sticks and brought them together, we no longer conceived them or considered them as 6 separate items, but we created the term 6 as a new compound symbolic definition. And this 6 was a unit or a unity composed of 6 parts. But we have, or did, establish the concept of a unity of consciousness toward these parts. Now this introduces what Pythagoras called the numerated soul. And he likened it to a quality in the universe, considering it to be a natural attribute of the divine geometrician, the great architect of the world, who designed all things according to number. The numerated soul is that mysterious intangible which comes in to ensoul or totalize groups of parts. Thus the 6 single sticks are really separate things, but the concept of 6 is possible because of the numerative soul in the world, which creates out of all separate parts an indissolvable compound. It then ensouls this compound totally, bestowing unity. We have the same thought in the Bible, where the reference is made, if 2 or more are gathered together in my name, I am in the midst of them. This gathering or totality results in the ensoulment of things by a composite being, which becomes the factor of intelligible unity, causing these separate things to become oneness, or something that we can liken to an analogy. Supposing we have 6 fairly large pieces of wood. A carpenter comes along, and of these 6 pieces of wood, he fashions a chair. Now this chair is actually these 6 pieces of wood, and as they laid along in a row, gave no concept of a chair. Yet when certainly joined, according to the skill of the carpenter, they become a chair. Where are the 6 sticks of wood in the concept of chair? And where is the chair in the concept of the 6 separate sticks of wood? Something has happened. And out of these pieces of wood, perhaps not especially useful in their original condition, has been created a new thing. A thing which has a name and a meaning, totally different from the individual pieces of wood. Yet it is composed of them plus one thing, the ordering power of the carpenter's mind. Therefore, in the universe, all things are composed of separate parts, plus the organizing power of the divine intellect. Man is a series of elements, of heterogeneous parts and members, which have neither integration nor organization. if separated from the builder that inhabits them. Therefore at death, there is a decomposition of the body, which is merely the resolution of parts back into a native substance. And the power which takes the body, made up of innumerable monads or separate units, and fashions it into a compound capable of sustaining the life of the individual and advancing his various physical, emotional, and mental activities. This compound is composed of parts plus an organizing mind. And this organizing mind, inanimate things, we call a spiritual being. Inanimate things, Pythagoras called it the numerative soul, inasmuch as it was a quality of life which ensouls forms or parts. And Pythagoras carried this concept further in maintaining that as man variously extended his faculties and powers, adding to the totality of himself through growth, he immediately became a new unit and was ensouled by a new numerative power. Thus an individual who possessed three arts and sciences has a unity composed of these three as a rational being. But if through study he develops two more arts and sciences, so that he is fairly the master of them, then he has a numerative power of knowledge to the unit of five, and he himself as a total being is changed. If therefore to the 6 pieces of wood be added 3 more, the numerative soul of 6 vanishes, disappears, returns to archetypal dimension, and the numerative soul of 9 takes over with a new unit consciousness. The same is true in all the things that men do, for all forms in nature are aggregations of monads plus the principle of the numerative soul, which measures their quality by their number. Number having a strange and mysterious power, which we know today in science, frequently comes to our assistance in estimating, for example, the basic atoms or electrons in various elements, determining the nature of the element by the number of its monadic parts. Also we determine sound by the number of its vibration. We determine color by the number of its vibration. And all things are therefore, in this way, numerative, or built upon the concept and principle of number. If to a certain color we add another tone, we change the whole of the color, creating a new color, composed of a certain number of separate color monads. And for this new color we have a name. When we mix yellow and red together, we have a new name for it, orange. And orange is neither yellow nor red. It is a new color, a new concept, and is one of those examples which Pythagoras pointed out, namely that the geometrician of the universe abhors divided natures, and wherever two divided parts are brought together in any kind of an arrangement, a principle of unity or an aspect of the numerative soul takes over, creating always unities, creating always a new oneness, a oneness composed of parts. Therefore we take hydrogen and oxygen, and we combine them, and we produce a new unity, which we call water. And in water, the mysteries of the hydrogen and oxygen are mysteriously hidden. We no longer recognize 2 parts of hydrogen and 1 part of oxygen. We recognize only water. So water again, on the level of elements, is a compound produced by the numerative soul, which which embodies or empowers totality and creates out of all combinations a new and complete unification. Now this brings us then to the next one of these Pythagorean theorems, and that is the affirmative negational numbers and the negative affirmative numbers. Now this is a rather intriguing thought, because we can immediately get to a concept of something, following the idea that one is unity, totality, and affirming what we have always held as ordinary thinkers, that God is one, and that God is totality. Therefore, we have the power to say God is one. This is an affirmative statement. This is therefore a pure affirmation, which means a positive statement of conviction, which is an affirmation. Always, therefore, unities of all kinds permit a positive affirmation. This is orange. This is God. This is a chair. These become positives. And therefore, all unities create the power of a positive statement of themselves, or an affirmative statement of totality. We have also heard, as I told you last week, that the Pythagoreans regarded the number 2 as a negative number. Therefore, representing as it does in the universe the principle of diversity, it signifies parts to which we have not attained the concept of totality. Therefore, if we wish to use the numbers to define God, we must use a negative affirmative. For we must say God is one, which is a positive affirmative. But we must say God is not 2, because we cannot assume division in the divine nature. We can therefore, in thinking of any number of parts, and using these parts, or any fragmentary existence in nature, in an effort to define divinity or first cause, we must always say in the negative. God is unlimited. God is not limited. We cannot say God is this part or that part. Therefore we must say that deity is not this part or that part, but God is the sum of parts. Therefore, wherever the concept of numeration or totalities come in, we can make positive statements of fact. But wherever we have division, and the reconciling or unifying or numerative soul has not bound them into a concept, they represent imperfection. And when we attempt to define the perfect, we may say it is either perfect, or we may say it is not imperfect. And when we say that it is not imperfect, we are then negatively stating that it is perfect. So wherever we observe phenomena, which is the observation of divided parts, we must say this is not totality. But wherever we preserve or perceive unity, we may say this is totality. Therefore, everywhere in nature, even on the lowest level of symbolism, whatever unities exist are elevated above disunities. And if of a number of things we must choose one to symbolize deity, we must naturally choose that in which there is the least diversity or the greatest unity. Pythagoras, affirming then that this is true, pointed out that the experience of God in the universe of divided parts is bestowed by the numerative power in the human soul, which is capable of the experience of at least the theoretical understanding of unity, so that man from himself bestows unity upon those parts which appear divided. And if he is capable of bestowing unity, he is then said by both the Pythagoreans and the Platonists to have achieved the intellective power. For the intellective power in man is the power to, from within himself, conceive a non-apparent but nevertheless real unity. In other words, the individual lives among strangers. And while he lives in a world of strangers, it means that the numerative soul within himself is inoperative. But when he comes to the conviction that these strangers are his brothers, that there is only one humanity, he may not see this, he may not be able to demonstrate it physically, but he has experienced it by the virtue of the numerative power within himself, which is the power to transcend the diversity and to bring all things back again to a concept of unity. Thus man, seeking for God, imposes unity, because within his own consciousness he has the internal numerative power to recognize that deity is numeration and creation is number. And therefore, to discover number is to observe diversity. To experience numeration is to recognize that all diversities are parts of unity. And therefore, he can intellectually conceive unity. This is also referred to as archetypal mentation, or the power to perceive patterns through things. The things themselves are arranged by the orderly powers of consciousness into patterns, and the discovery of these patterns is a series of experiences in consciousness, which may be defined as apperception or intuitive realization, or if extended to a sufficiently high level of experience, may properly be termed illumination, or a mystical ecstasis, which is the experience of the numerative power uniting all things inwardly and eternally, although they may not be so united when explored or examined by the sensory powers of man. This brings us again to another Pythagorean theorem, and that is the statement of the pentagram. Now, the pentagram, or pentalpha, as it was called by the Pythagoreans, was the symbol of healing. And Pythagoras is said to have worn upon his finger a ring ornamented with a 5-pointed star, this star being composed of continuous unbroken lines, forming this pentagonal figure. Now, the 5, of course, represents the sensory powers of man. For the ancients recognized 5 operative sensory perceptions and 2 latent ones. The 2 latent ones, however, arising from the perfection or development of the 5 lesser. Now, as these 5 senses which man possesses are in themselves separate, they may be likened to 5 sticks, or 5 of anything. But when they are united by the numerative power of the soul, they become a new thing. They become the pentagon, or they become the pentad, which is a unity. And when the faculties of man are united in this state of indivisible unity, to form a new kind of thing, a new faculty. This becomes, to the Greeks, the apperceptive faculty, which is born from the chemistry of the union of the five sensory powers, but is itself a sixth power, or one which is totality. And this sixth power immediately assumes the proportion of unity, and is therefore capable of the true perception, or true examination of phenomena. Because it is this power added to the five, which permits the five senses to perceive all things as unities, rather than as diversities when reported by their separate powers. We see then that there are a great many different ways in which the Pythagorean arithmetic becomes a key to study and theory and logic and reason in many different branches of human experience. Now we have another interesting and important thought here, and this is Aristotle's system of what he called converging deletions. Now these terms are a little more dangerous by sound than they are by fact, so we just suggest that you pass over the terms, and I use them merely for convenience in reference, in case you should want to check with some standard work on mathematical philosophy. But the system of converging nullities is a very simple thing, in fact, and that is by use of fractions. In the use of fractions, you can arrive at 9/10 of totality, or you can arrive at 99/100ths of totality, or 999,000ths of totality, or 9,999 10,000ths of totality. But in your system of fractions, you are always going to fall short of totality. Now, the interesting point is that the further you carry this series of converging nullities, the nearer you come to totality, but you can never reach it. Actually, 99/100ths is nearer totality than 9/10. Because 9/10 is only 90/100ths. And so on. But if you go into the most inconceivable sums that you can possibly imagine by this fractional process of convergence, you will still lack something. You will always lack one part of the total fraction. In 9/10 you lack 1/10. In 99/100ths you lack 1/100th. In 999,000ths you lack 1,000th. So if you go on far enough, it will seem as though you should be able to drift to totality, but you can never do it, because there will always be one lacking. And here Pythagoras used this to represent another way of approaching the concept of the numerative soul. For this missing unit, or this missing fractional unit, always represents that which falls short of totality. And yet wherever it is imposed in any of its strengths or weights, it immediately consummates totality. Therefore, unity as a concept or as a numerative principle added to any deficient thing creates totality. Thus it becomes a kind of negative representation. Does not say that God and one is a majority, but rather says that any number plus God is totality. And this becomes a curious concept, because one, in this case, also represents the principle of indivisible unity, which imposed at the end of all diversity will restore unity. Now, Pythagoras pointed this out in a very interesting analogy, which has very practical consideration for it. Namely, that man may gradually grow upward, from various percentages. He may grow from 1/2 to 2/3 to 3/4 to 4/5 to 5/6 and so on to infinity. But he will always fall short one of totality. He cannot reach it on the fractional basis without the addition of totality. And this totality implied to Pythagoras that man, through intellection, through growth, through study, through science, philosophy, art, music, literature, may gradually reduce the interval between himself and totality. But the final consummation of totality is the bestowal of grace by God itself, which is the missing number, which cannot be supplied by the fractional parts, but must be bestowed. Therefore, the totality, which represents the completion of any task, like the mysterious missing capstone of the pyramid, you can build as far as you want to in number, but you must always have the concept of the divine number, or the divine power 1, added to any of your works before that work can be perfect. This he developed quite extensively, but I think for our purposes that will carry the general thought and give you the principle upon which this operates. Now we also have another group of numbers. In fact, there are probably 200 or 300 of these number pattern groups. We cannot touch them all, we won't try, but we will try to point out a few to give you the general picture of the implications of this extraordinary philosophical speculation. We find, therefore, among the Pythagoreans what was called the Sieve of Eratosthenes, the sieve of the numbers. For as a sieve allows certain small materials to pass through, but blocks and stops larger materials than can pass through the sieve, so there was a mathematical sieve by which all numbers were inevitably divided into 3 kinds: perfect numbers, superabundant numbers, and deficient numbers. Now, perfect numbers are the rarest, inasmuch as the perfect number becomes the symbol of absolute equilibrium. There is only one perfect number between 1 and 10, one perfect number between 10 and 100, one perfect number between 100 and 1,000, one between 1,000 and 10,000, one between 10,000 and 100,000, one between 100,000 and 1,000,000, and so on. In each of these major divisions, there is only one perfect number. The simplest and most common of the perfect numbers is the number 6, which is the number between 1 and 10. The reason why the number 6 is termed a perfect number is because the sum of its parts is equal to itself. A half of 6 is 3, a third of 6 is 2, a sixth of 6 is 1, and 3, 2, and 1 equals 6. Now those are the only possible divisions that can be made, equal divisions, that can be made of that number. And the sum of the parts equals the number. Therefore this is termed a perfect number. 8, for example, can only be divided in certain ways. A half of 8 is 4, a fourth of 8 is 2, and an eighth of 8 is 1, which makes 7. Therefore this is a deficient number, because the sum of its parts is less than the number itself. We take the number 12, for example. A half of 12 is 6, a fourth of 12 is 3, a third of 12 is 4, a sixth of 12 is 2, and a twelfth of 12 is 1. The sum of these is greater than 12. Therefore, this is a superabundant number. Now, in this problem, superabundant and deficient numbers are comparatively common. And the reason that Pythagoras made use of this particular calculation is to exemplify, in part, the importance of equilibrium in the achievement of human consciousness. Therefore, according to the Pythagoreans, where the parts are in excess of the totality, we have a superabundant number. Where they are deficient of the totality, we have a deficient number. Now this has to do with the power of the numerative soul to control the totalities. because with the exception of one class of numbers, the numerative soul in man is not capable of controlling all parts. And those parts which are not controlled are called deficient numbers, called superabundant numbers. Those in which the control is unable to mass the lesser parts, and the totality is therefore hypothetical. In the presence of a power not properly developed or organized, we have a deficient number. But where the parts and the whole are equal, we then have a true number, or a perfect number. And the study of arts and sciences, particularly, have to do with this. Because, for example, if the teacher does not know enough, he is a deficient number. If, on the other hand, the teacher, knowing much, does not take into consideration the ignorance of the student, he is a superabundant number. Because the totality of what he has to give cannot be received. Whereas if the teacher and the pupil have a full and complete understanding, and the student receives all that he is capable of receiving, and the teacher judiciously gives that which the student can use, the result is a perfect number. Therefore, the relationship between man and the world, a phenomena, is here indicated. The individual who sees less than there is to see is functioning with a deficient numerative power. If he sees more than he can understand, and surrounded with wonders comprehends nothing, then there is a superabundant number, because his total integration does not permit him to understand that which he sees. There are hundreds of applications of the principles, but this is the basis upon which the concept was built. And of course, each of the numbers involved in these patterns has its own significance, but that is a very big subject, because each one of these numbers is made up of a certain combination of numbers. And these in turn, like the elements in a chemical compound, each has a distinct meaning. And from these distinct meanings, we have a great deal. For instance, the number 6, which is the first of the perfect number, is also in the Pythagorean concept the number of marriage, because it represents the basic unity of divided parts. The number 6 being the proper symbol of union, and therefore it is a perfect number, because it encloses or concludes a totality. And of course the three divided parts of the number, the half being 3, the third being 2, and the sixth being 1, becomes the basic family unit, father, mother, child. And the same number on the level of the universe is related to the days of creation, and the three equal parts, which total to itself, are the three persons of the Trinity. Every part of this numerical system becomes extremely complicated, but out of it almost anything that you wish to conceive and rationalize and understand can be developed, so that it becomes a magnificent system of theology as well as a system of science. And that is one of the things we feel so badly about in connection with modern education, because the advanced books of Euclid are largely devoted to the great numerical speculations of Pythagoras. And yet these higher books of Euclid are not available to the average student. And the so-called Euclidean mathematics that we have merely carries us through those primary parts which are concerned in barter, exchange, architecture, and things of that nature, and give us no concept of the great philosophy of numbers with which Euclid himself was well familiar, and which he attempted to develop in his more advanced works, which are not even available to the public in general today. So the mathematical subject becomes a very much bigger one than we first realize or understand. Now, out of this problem also, we come to what has been termed the motion of number, which is one of our primary considerations this evening, so we're going to have to take more time with it. I wanted to try and sort of sprinkle in a little bit of Pythagorean thinking, so you'd have some grasp of the field of his mind and how the mathematical philosophy developed. Now, the motion of number is either from 1 to 10 or from arithmetic to geometry. The ancients reasoned, therefore, that on a horizontal plane, the numbers unfolded from 1 to 10. On a vertical plane, they fell from arithmetic to geometry. And this double motion of number became very, very important in their philosophy. Now, Pythagoras, like all the ancients, began the entire concept of mathematical philosophy with the hypothetical dot. The dot, or point, is the beginning of all form, all numeration, and all motion. The dot itself is the principle of numeration, and the circle is the circumference of number. Therefore, the dot precedes and the circle terminates. The dot precedes the descent from arithmetic to geometry, and the circle consummates the extent or extension of numbers from the 1 to the 10, or the cycle, the complete cycle of numbers. Thus, in a sense, the circle is an exoteric dot, and a dot is an esoteric circle. The dot is archetypal. The circle exists in the sphere of creation. Therefore, it is customary to conceive of total being as a dot, and of total existence as a circle. And the dot placed in the circle is being in the center of existence, or being in the center of the cycle or circle of its own field, or its own extension into totality. In the Hebrew Kabbalah, the dot and the circle are placed in the form of a human eye. The opened eye being the symbol of manifestation, and the closed eye being the symbol of the universe in abscondita, or in suspension, in the divine mind. Therefore, creation was represented in the Kabbalah by the opening of the eye of the Great One, or the Great Being, which immediately revealed the mysterious mathematical form of the dot and the circle, or the central point of the eye in the field of the iris. Now, the dot, by motion, can move only from itself. It can never approach itself, because it is hypothetically forever center. Therefore, the only possible motion of a dot is away from itself, and this motion is called a line. And the most primary of all lines is the number 1, which is the first vertical drop of the dot. The dot, descending from its own state into the circumference of the circle, first produces a line, which hypothetically becomes the radius of the circle also. But the dot, extending itself away from itself, creates the line, which is the most simple of all the basic mathematical forms, and the line itself becomes 1. Now, the line, moving away from itself, can produce only another manifestation, for a line moving from itself produces a circus, because all of the line has to move, and the line moving away from itself causes a flat circus. Therefore, this is the second, or area. And this area sets aside a certain level called a plane, and becomes the basis of a different level or concept of existence. And when the surface moves away from itself, it can move in only one direction. The whole surface must move. Therefore, a surface moving away from itself produces a solid. And there we have the fall of arithmetic into geometry. And the solid, the most simple of all mathematical solids, is the tetrahedron, or the 4-face symmetrical solid composed of each face of a triangle. This is the smallest number of faces that can enclose an area. Therefore, if you will consider carefully your mythological and your religious systems throughout the world, you will realize that the number 4 is always very closely associated with the concept of God. Now, the concept of God in this sense is the concept of what the ancients call the demiurgus, or the creating deity. In other words, the God in creation and of creation. The God that moves upon the face of the deep. Deity in the sense of a creating power. This is not absolute deity or absolute being represented by the dot. This is deity moving into quantitative and qualitative manifestation. Qualitative manifestation being determined by the geometrical solids, and quantitative manifestation by the extension of the numbers from 1 to 10. Now there is a large thought hiding in this pattern, a very large one, and it involves a number of very interesting and remarkable fields of research. For example, the number 4 is an even number composed of even numbers, 2 2s. It can also be composed of a 1 and a 3, which gives us 2 possible forms by which the 4 can be fashioned. Going back to our other theory that we just had, if we take 4, a half of 4 is 2, a fourth of 4 is 1, the sum is 3, which makes the 4 a deficient number. So you have to begin to work these systems in and with each other. Therefore, we recognize that the ancients understood the 4 as the symbol of creation, of the objectification of the material universe, as the 4 elements, and as the great field of form generation. Therefore, the number 4 is the archetypal number of form, and the concept of form and the solid, the least of the solid forms, gives us form and solid as being identical in concept. Now we go to another interesting point, which is made for the Greeks and also has been made for the Hindus, and one that we are comparatively unaware of. Namely, that creation is a deficiency rather than an addition. Creation is not what we think it is. Creation is the addition or the manifestation of the greatest solidity existing within the greatest density. Now, the dot, or space, is the greatest density, because space is absolute fullness. All conditions are less than that. Therefore, it is said in Egypt, and also among the Hindus, that when the time came to create the world, the Ammonian artificers, the Elohim of the Bible, took their knives and made holes in space. And forms are holes in space. Now that is quite a problem, but it's an interesting one. Because density is a greater and more enduring thing than solidity. A rock is more solid than the air around it. But the air is more dense than the rock. And space, which permeates the rock, permeates the air, and permeates everything, is actually more real, more enduring, more substantial than the rock. The proof of that is that the rock comes into being from space, abides for a time, and will ultimately return to space again. Every rock that ever existed was once in space, invisible. And every form, every world, every planet, every solar system, which appears as a solid form, is a solidity emanating from density. And everything that exists is ultimately going to disappear again. And when it disappears, it passes from a state of solidity to a state of density. And when it reaches the state of density, it reaches the state of permanence. Because density is eternal. solidity is not. Anything that is solid is a compound. And as Lord Bacon put on his own gravestone, all compounds shall be dissolved. Therefore, actually, ignorance is a hole in truth. It is like an opening or an empty place. Form is a hole in space. Because in form, eternity is privated. As the Pythagoreans say, the universe was formed by the divine power retiring from the circumference to the center of itself and leaving a vacuum. This would seem exactly the opposite. There are certain metaphysical groups that teach that we appear to be here, but we're not really here at all. And it would be rather embarrassing to realize or to have the thought that we're really holes in the air and not here at all. And we're not going to go to any such extreme as that, or anything of that nature. But qualitatively, the state of separate existence is less than the state of total existence. Therefore, every separate thing is inferior to totality. And as all created things are separate things, it is inevitable that their quality is less than that of totality. Therefore, they are a conditioned existence existing within an unconditioned state. And that conditioned existence is inferior to the unconditioned state. Therefore, on the terms of exact definition, things are less than that no thing which is their common source. And things are not an abundance of things. They are a deficiency of things. And that is why you have to add them all together before you can get one. In other words, if we were positive beings, then if you added us all together, you would get many. But where we are deficient beings, it is necessary for us all to be added together to neutralize or compensate for the deficiency. If each individual was a plus in an atmosphere which was a minus, he would then be complete in himself. But as it so happens in the universe, if you add all existence together, the sum is space. Therefore, each existence must be less than space, or be deficient. This is one of the reasons why we fill up the vacuum by coming together. And when we have all come together, then we have neutralized and have created again the fact of space itself. This underlies the Buddhist concept of nirvana also, which is not the loss of something in the unknown, but rather the loss of that which is not in the totality of that which is. No thing then can cease, except in the sense of its return to its own totality. And because our sensory perceptions are incapable of the concept or vision or sensing of totality, that which passes from a fractional condition toward a unity passes out of the contemplative range of man, and therefore is said to disappear or to no longer have existence. On this theme, of course, you could do a great deal in the Pythagorean speculation. You could have really quite a holiday working with this phase of the Pythagorean mathematics. This brings us to another point that we have to dwell on for a moment, and that is the great symbol of the Pythagorean school, which was the Tetractys. Now, the Tetractys is a pyramid of dots, consisting of 4 rows of dots. The first row with 1 dot, the second row with 2 dots, the third with 3 dots, and the fourth with 4 dots. And these are arranged in the form of an equilateral triangle with the apex at the top. Now this system or sequence of dots, according to the Pythagorean theory, was the perfect symbol of the numerative soul of space, because within this design was bound up all the mystery of numbers, and the Tetractys itself was the totality which constituted the soul image or pattern. The Tetractys was the symbol of the perfect ensoulment of the number by archetype. And as it was equilateral, it could be approached from any direction. And because it was an equilateral triangle, it was 1/4 part of the pentagon, or four-sided symmetrical solid. The Pythagoreans used what was called the greater and the lesser Tetractys. The concept was later borrowed by the Kabbalists, who involved it in the structure of the Sephirotic tree, or the 10 mysterious blossoms upon the tree of life, by which they represented all the worlds, creation, and all the patterns of existence. Now the total of 1, 2, 3, and 4 is of course 10. And therefore these dots complete the decimal units. And the Pythagoreans held them in their various combinations in the greatest and the most profound regard. They became a pyramid of number. The pyramidal form itself being the form of the Greek letter D, or delta, which in itself is the first letter of the name of deity. So that there was an additional importance in the form itself. The Hebrew mystics took the same design, and instead of the dots, they used little marks resembling commas, which were the Hebrew letters Yod, the most sacred or fire letter of the Hebrew letter, which peculiarly symbolized spirit and life. Later, the Tetractys was used also Kabbalistically in connection with the Tetragrammaton, or the 4-letter name of God, which we pronounce Jehovah, which is composed in the Hebrew of 4 letters, IHVH. Therefore, in arranging the dots, they placed the I on the first line, IH on the second line, IHV on the third line, and IHVH on the fourth line, letting one of these letters, therefore, represent each of the dots. From this they formed also an equilateral triangle, in this sense composed of the name of God, and the most important of the names for deity to be found in the Kabbalistic system, a word which is not usually spoken by an Orthodox Jew. When he reads it in the Bible or comes across it in sacred writings, he substitutes the word Adonai, or Elohim, to signify Lord or Lord of hosts. He does not use the word itself, because to him it is a sacred and secret name. The basic Hebrew alphabet is composed of tiny comma-like marks which are called flames. And in all probabilities, the original forms were taken from star groups. And these form the handwriting on the wall of heaven, and the Mesoretic dots or points or diacritical marks which were added represented the motion of the planets through the signs of the constellations, thus spelling out words or giving new meanings to the consonantal groups. So in the Hebrew mysticism and in the Greek also, we find the tremendous importance, Kabbalistically and magically, of this mysterious symbol, the symbol of the Tetractys. Now the Tetractys arranges the dots, therefore, upon 4 levels. The first level having only 1 dot, the second level 2, the third level 3, and the lower level 4. Thus there is an automatic division into 4 rows of dots, of which the first row, of course, contains only the single dot. Also in arranging these dots, a certain number of intervals come into existence, the spaces between dots. And it is relating to the problem of interval that we have the motion of number. Because motion is always motion through or cross interval. And everything that exists in interval. And in the study of philosophy, we become gradually more and more conscious of interval and less conscious of incident. Incident is to us formal, relating to solidity. Interval is non-formal and relates to the principle of density. Therefore, solidity moving through density is thing moving through interval. Now, the example of this on a practical level can be taken from the philosophy of history. We have, for example, historical incidents. We know when Columbus discovered America. We know that there is nothing less important than the memorization of that date. We know 1492, but it means nothing apart from context. The fact that in 1066 William the Conqueror stubbed his toe on the soil of England is also a magnificently unimportant fact. And this gives us what the Pythagoreans expressed as the danger or menace of fact. Because all facts are static. The spaces between them are dynamic. All things, therefore, are in themselves factual. The intervals between them are susceptible of something greater than fact. For a fact is different from a truth, and a truth is different from a reality. Consequently, when we study history, or we take words, it is not the words themselves, but their arrangement that becomes necessary to the transference of idea. And this means that some people with a very large vocabulary never say anything. And some of the greatest teachers of English in the world have never had a thought. They have a magnificent instrument, but they've never used it. Because the facts or the substances themselves are meaningless unless you put them to work. And a thing to work must have space to work in. And space is interval. You cannot get a carpenter to work unless he has elbow room. He has to have space. And space requires motion and implies it. And all action implies the need for space in which to move. And of course this we can't help but remember at this time, one of the pet problems of ancient knowledge. If you can solve it, why, you're very good. One man by the name of Euclid, not our friend the mathematician, but another Euclid, which was a common name in Greece in those days, is said to have committed suicide over this problem, the problem of motion. He said, for a thing to move, it must pass from the place where it is to the place where it is not. And as all things must be inevitably in the places where they are, can anything move? That thought cost him his life. He was never able to solve the mystery. What he did not have probably possessed was the Pythagorean realization that the motion of the dot produces the line. Therefore, things can move. And yet, the motion of the dot in producing the line does not take the dot away from where it is. It merely extends the dot into a dimension. And this dimension, in turn, is the principle of motion. Now, to return for a moment to the problem of history. History is significant only because of perspective upon a problem. History is a point. Now is a point. Now is a point of importance because of two intervals represented by two other hypothetical dots. For on one side of now is a dot which is called the past. And on the other side of now is a dot which is called the future. And between the past and the present is an interval. And between the present and the future is an interval. Now our estimation of values forces us to bridge the interval between the past and the present, and leads us inevitably by the imaginative power of the mind to bridge the interval from the present to the future in the terms of the preceding interval. We follow the admonition of the Babylonian deity Nebo. What has been, will be. Therefore we say, 500 years ago, people did a certain thing and this happened to them. Therefore, if today we observe people doing the same thing, we assume that in the interval of the future the same thing will happen to them. Thus, by means of these two intervals, we orient the present, and we use the past as an instruction, and we face the future as an opportunity. We also recognize that the interval of the future is always partly bridged from both the present and the past, but that these bridges are susceptible of modification. And as Pythagoras expressed it, nearly every individual who is working for the future is trying to modify the inevitable. He is trying to make some changes, lesser or greater, in patterns which otherwise will remain unchangeable. That is the basis of politics, the basis of education, the basis of reform, is that if the future extends in terms of the present, it will be inadequate. Therefore, the problem of the contribution of the individual or of the collective to the modification of the inevitables of the future, this effort constitutes change or motion, qualitative motion. Now, quantitative motion and qualitative motion are two different things. A thing which goes a mile on the ground achieves a certain quantitative motion. An individual who, being not intelligent, becomes more intelligent, achieves qualitative motion. For qualitative motion is in terms of improvement of quality. Quantitative motion is in terms of spanning of distances upon a level. It is therefore said that qualitative motion moves on an oblique line mathematically, and quantitative motion on a horizontal line. And Pythagoras added that illumination or spiritual motion moves on a vertical line. Therefore, we have the spiritual life of man represented by a vertical, his intellectual psychic life by an oblique, and his physical life by a horizontal. And in one of the old mystery systems of the ancients, it was customary to initiate the candidate by raising him from the horizontal to the oblique and from the oblique to the perpendicular. This symbolism is significant to some people. In the same concept, qualitative motion, because it is an ascending motion on an oblique, becomes the motion of the human soul or the human mind. We will find some more about that in the hypotenuse of the 47th proposition of Euclid, which we will take up in another discussion. But we have in that hypotenuse the three lines, the horizontal, the vertical, and the oblique. And in this we have the story of the life of man, the entire psychic field of human growth and progress. If, therefore, qualitative motion is upon an oblique, thereby all growth is an ascending arc or ascending line. This means that the circle of material activity is changed into a cycle of psychic activity, because a cycle is a spiral and a circle is upon a surface. Therefore, a spiral is an ascending circle. And Pythagoras taught that the soul of man is so constituted that it can never, under any conditions, repeat itself in anything. If it appears to repeat itself, it repeats itself with a certain qualitative interval by which the circle has been changed into a cycle. The reason for this is that no individual even though he walked the same road every morning, can be identically the same person in 2 different days. The individual who Monday morning very carefully follows a certain path and comes back and goes over it again Tuesday morning. The path is the same, he has followed it the same, but something has happened to him in the meantime. He is not the same person in every particular. During the interval, he read a newspaper. That was enough to change him, probably for the worse. And during this period of time, he has perhaps made a new friend. He has read a new book. He has heard a new report. He has studied something. He has improved himself in some particular. He has made a new friend or lost an old one. Perhaps he's made an enemy. But he's going to learn even from that. He is not identically the same person. Because in the 24 hours difference, some changes, some thoughts, some experience, even though trivial, must have occurred to him, by which the numerative soul compound of himself is different. And because this individual, always different, can do the same things, but is himself never the same, Pythagoras used the spiral to represent a return to a similar point, but not an identical one. Because in the return, the oblique line of growth has resulted in a gradual ascent, even though it may be an extremely slight ascent. This is the basis of the entire cyclic concept of evolution as we have it in the modern world. So here we have the problem of interval. And we have these dots in this tetractys surrounded by intervals. Intervals also are what the Pythagoreans call tonal interludes. Every single interval in nature has a tonal equivalent. Pythagoras pointed out that the difference in tones are not due to the essential substances involved, but in the case of a musical instrument, the location and placing of the frets. In other words, the intervals on the same string create different tones. Therefore, you may have the diapente or the diatessaron according to the placing of the frets upon a string, and the length of the intervals between the frets determines the tone, and not the fret itself nor the string. Therefore, in the Pythagorean system of astronomy, the music of the spheres was not based upon the concept that the planets had tones, but that the intervals between the planets were tonal. Therefore, Pythagoras divided the heavens from the earth to the empyrean into a single chorded instrument, which he called the celestial monochord. He placed the frets in the locations of the planets, and then declared that the intervals between these constituted the basis of the sidereal harmony. The Greeks, accepting this process and concept, created their idea of modal music, the modes being arrived at by the rearrangement according to mathematical formula of the frets relating to the various strings, in the same way as we tune an instrument today. Thus we come back to a very important point in connection with the Tetractys, namely that all these rows of numbers consist of numbers and intervals. Now, for example, on the lower line, we have 4 dots. These 4 dots, therefore, enclose a certain number of intervals. And how many intervals do we have between 4 dots? Quick, somebody. 3. Well, I just want to make sure everyone's awake. All right, 3 intervals and 4 dots. Now, this in itself gives us a very significant number, the number 7. Therefore, we have 4 things and 3 spaces constituting a septenary. Now, if we, for instance, want to go into the old symbolism of Freemasonry, we remember the master mason's apron, which consists of a square into which falls a triangle. Here is a septenary. Now, in this septenary also, we can go back to our ancient Hindus and Babylonians, who, placing a pyramid upon a cube, declared this to represent the entire structure of the world. 3 constitutes the divine numbers, or divine number of equilibrium. 4 constitutes the number of forms. Therefore, within the 4 dots of form are 3 intervals, or spiritual interludes. And these constitute what the Pythagoreans call consciousness, intelligence, and force. They are all intervals, or interludes. They are energies invisible. They are the field in which the 4 dots operate. Therefore, the 4 elements are held together by 3 spiritual powers, which are termed binders, or are termed the materials or substances necessary to the manifestation of these dots. Now comes a very nice question. We don't have to go out and follow Euclid, commit suicide over this, but we do have a delicate issue. What happens to the intervals if you take away the dots? That's what an English cricket player would call a sticky wicket. Now, what do we do about this? If we take away the dots, the intervals are lost. We can't take away the intervals. If we take away the intervals, the dots merge together, because they are held apart or exist separately because of interval only. So if we remove one of those dots, we remove with it one of the intervals. Therefore, we come to another very interesting thing, a problem that has been asked many times on another level. If you were out and if an explosion occurred where there was no one to hear it, would there be any noise? That's one of the very, very old questions. And that's been subject to a lot of analysis. The question then, of course, remains as to the meaning of the thought or concept of noise. If by noise we mean only that which is the result of certain vibration to the eardrum, there could be no noise if there was no eardrum. But there would still be a vibratory circumstance of some nature, whether anybody heard it or not. But it would not be sound unless there was an ear to hear it. Now, we have the same problem in connection with dots and intervals. Energies could not manifest unless there were forms through which they could express themselves. Therefore, the moment you take away a number, you remove all of the manifestation of the intervals contained within that number. You also will discover as you proceed that the intervals are always one less than the number. And therefore, that in all these various problems, you always have an interesting situation. If your intervals are even, your numbers will be odd, and so on down through the entire problem. And as you have in your odd numbers, your positive numbers, and in your even numbers, your negative numbers, there are certain compound in which intervals are positive, and other compounds in which the objects or the numbers are positive. This again opens a very large field of Pythagorean speculation. But we are dealing primarily with the recognition that all patterns of number release into objectivity measurable intervals, which cannot be measured until numbers are established. The moment you establish 2 dots in 2 places, you can measure the interval between them. Take away one of the dots, the interval remains but becomes immeasurable. It becomes one with eternal interval the moment your boundary is removed. Therefore, you can measure an interval between things, but not an interval between one thing. Because the interval between one thing and totality is always the same. It is essentially immeasurable. Therefore, where two or more things come into manifestation, separate interval comes into existence, and Pythagoras called interval individuality. Now, this again becomes quite a stimulating thought, because individuality for its existence requires the number 2, because it must have boundary and interval. And within an interval between the two dots of the Tetractys, individuality can exist because the relation of the two dots to each other can be changed. And because of that, individuality can be infinite and still measurable, in the sense of infinite number of possible association of the two dots. But that association is arithmetical, because it is on a level, or on a line, or on a plane. No matter where you place the two dots, a line between them is a hypothetical horizontal. Therefore, there can be no dimension beyond the dimension of the line in the connection of any two dots. Consequently, the entire concept of this interval is interval on a surface, because actually the two dots can be the ends of a line. And hypothetically, a line connecting them has these dots for an end, for ends. Thus, however, if we have duality, this duality as two dots captures and holds an interval, and this interval becomes individuality and measurable. Removing one of these dots restores unity, and the moment unity is restored, individuality becomes immeasurable. Therefore, there can be no individuality in unity, per se, because unity cannot limit anything. The moment, however, you place a line between one dot and another, that line becomes an imaginary radius of a circle, and the interval becomes the radius of the circle of individuality. This is developed along the concept which the Pythagoreans held, that the moment you establish the consciousness of identity or unity, you destroy the illusion of interval. Therefore, the achievement of total unity destroys the interval between self and eternity. For the universal is equidistant from that which is only one dot. But it is divided into a hypothetical interval plus another interval, where another dot is introduced. For example, if you have two dots and infinity, you have two intervals. The interval between the two dots, measurable, and the interval between one dot and eternity, immeasurable. Therefore, you have what is called measurable and immeasurable interval. Measurable interval carries with it the entire intellectual life of the individual. And if you assume that these two dots are then connected by a thread, that thread is the single chord of the monochord. And wherever two dots are established, the thread can be extended between them. The interval can be considered an octave and broken up into a group of harmonic and inharmonic intervals, so that the intervals between the dots, regardless of its hypothetical length or shortness, becomes a total tone, susceptible of division into a complete range of tonal qualities. This in turn produces from itself what the Pythagoreans considered to be the concept of the solar system and the universe. For the universe consists primarily of that which bridges primary interval, which is the establishment of the two dots. Now these two dots are subservient to and inferior to unity, because they are halves of the principle of unity. But between these unities, these halves of unity, or divided parts, is an interval which can be mathematically cut, either by what is called the equal or the unequal cut. And by this equal or unequal process of cutting, an entire group of psychic potentials are released along this thread or cord which unites two bodies in interval. Now we also have another use of the type of the concept of interval in music. We have interval in terms of pause or a break of tone. We have interval in terms of the spacing in rhythm and in practically all musical motion. So motion is rhythmic as it extends through interval. And the various possibilities of these rhythmic motions through interval become the basis of the various types of motion which can exist in space. Now Pythagoras conceived of this primary interval as being broken into a series of unequal parts which are called numbers. And these numbers, extending from 1 to 10, are represented by frets, which give upon this string 10 possible tonal lengths. These tones, in turn, through their various vibratory lengths, produce by vibration another motion, because we have at this time considered only motion in terms of interval between two dots. The vibration of a string produces another kind of motion. This is the motion that you get, for instance, in an electrocardiograph. Because in an electrocardiograph you have not only the motion on a level or on a line, but you have an eccentric motion, which we would say on the cardiograph is up and down. In other words, the motion is not a direct motion, but maybe a broken motion, a jagged motion, an angular motion consisting of curves or angles ascending and descending from the line. If we could see under very powerful magnification a string which is sounding, we would observe that this string is moving back and forth on its own axis, that there is an ascending and descending arc on each side of the string in motion. Therefore, we develop in the concept of motion not only a motion from one place to another, but an up and down motion, or a motion crossing the original line of motion. This, according to the Pythagorean system, was very, very important. For just as the individual learning to write may first draw a line, then make upper and lower lines from this, achieving an irregular motion, so in the terms of the Pythagorean theory, this quality of motion not only occurs upon a line, but within the scope of a solid, inasmuch as hypothetically a solid could be constructed upon a line in motion, and the vibration of the line would strike all surfaces of the solid. In other words, if you placed a hollow cube with the ends removed around a moving string, if this string was vibrated sufficiently, or the cube was small enough, the string would strike all the surfaces of the cube while in motion. I hope that point is clear. I'm trying to make it so. But in other words, your string is moving in a variety of directions in the process of vibration. The motion is very slight, but nevertheless it is true and real, whether we can see it or grasp its import or not. Those of you who saw Fantasia, the motion picture, will remember that Stokowski, in one part of the picture, created some diagrammatic representations in light and color of the motion of strings in a musical instrument. This is the type of thing which we are trying to call to your attention. Namely, that this vibration requires not only surface motion, but requires motion with depth and dimension. And therefore that motion inevitably leads from surface to solid. And that all motion gradually develops polarities and becomes a solid field. Moving things become solid fields while they are in motion. This is an important point because in modern researches, the motion of space and the motion of the continuum is causing us to contemplate that in the solid intervals of this vibratory motion, there may be other complete orders of life beside the ones that we know. In other words, in the dimensions of motion alone, there is the possibility that this same space that we occupy could be occupied with a multitude of other creational systems, which we cannot see and cannot realize and cannot know exist, because they exist in the intervals between the vibratory rates that we know, or that we have come to recognize. In the interval problem, then, we have in the Tetractys of Pythagoras each dot surrounded by total interval. The distance between all dots is the same, except upon the circumference of the figure. For the outer rows of dots have intervals to those below or above them, except for the top, which has only intervals downward, and the bottom, which has only intervals upward. But the figures themselves are surrounded by equal intervals, and the entire figure is suspended in interval itself. In other words, in total interval. It would be quite natural and reasonable, then, to conceive these figures as representing the entire theory of what we call today vibration, with which the ancients had already made calculations, but about which they did not have quite the concept of exactitudes which modern science has made possible. But they were working upon this principle very definitely. Now, considering the Tetractys as monads, or as units of life, and following the concept of Leibniz in his monadology, we know that all forms are aggregates of monads, of which the Tetractys is the ideal archetype of organized form. Therefore, we say that these monads, in themselves and of themselves, could be floating like specks of inconceivably minute dust forever in space, without organization or arrangement. We may assume with some of the early thinkers that these monads radiated sufficient energy to make impossible the striking of one against another. Even this, however, is a doubtful hypothesis. The second is that these monads could accidentally meet and merge and mingle, thus creating compounds. The Pythagoreans held a rather different attitude on this, however, because they used the principle of interval to cover the entire concept of the field of monadal activity in space, assuming that monads of themselves could not be superior to themselves, and that these various monadal units were relatively equal, though perhaps diverse in quality, but that they were not susceptible of domination over each other, and each had only a separate and complete subsistence in its own nature, and each was a unit of eternal energy in its own right. Then came the problem as to how these primordial monads were brought together in the organization of the universe. Leibniz suggested that there was a concatenation of monadal archetypes. In other words, that monads were parts of larger monads, these in turn of still larger ones, and that there was thus an orderly progression of monads, with infinite diversity at its lower extremity and unity as the supreme all-enclosing monad at its apex. In this thinking, of course, Leibniz was very, very much a Pythagorean, because he conceived of the single monad as being the all-inclusive archetype, and followed Pythagoras in the concept that existence and development and growth exist within archetype. Now we think of archetype as pattern, and many persons, even following the Platonic concept of archetype, feel that these forms or images held in the divine mind are, as it were, sketched or drawn upon the surface of consciousness, and that all things more or less receive these impressions into their structures, and are therefore copied from ideal patterns. However, both Pythagoras and Leibniz were of the opinion that the archetype is the all-inclusive monad of anything. Therefore, that all things that bear a certain archetype exist always within that archetype, and that that archetype occupies a place, and that that place is the total sum of its own parts. Thus, all forms of life that have an existence under patterns are within the pattern. They are not merely copying it. They are not merely following it. It is not merely projected upon them. They are totally and continuously and eternally within it, because all parts are but miniatures of the totalities of which they are parts. Therefore, they can never be separate from their own totality, except on the level of phenomena. On the noumenal level, they cannot be separated. Thus, the archetypal pattern of Pythagoras implies that the whole universe, everything that exists within a monadal archetype, which is the Tetractys, or the great sequence of the numbers, surrounded, as it were, by this flaming symbol of the upright triangle, a universe unfolding within the boundaries of consciousness, intelligence, and force, which are the lines of the triangle, or the three sides of the delta. This is the same delta, of course, that was said to have been hidden by the patriarch Melchizedek in the depths of the royal arches, and was later found and restored by Enoch and Methuselah. Now in the Tetractys we have also a number of numbers that we must think about. On the first row we have the monad alone. This tells us that one is superior to all. I've told you before that Pythagoras did not regard the one or the two as numbers, but the one and the two are placed in the archetypal form. For the archetypal universe itself has as its archetypal pattern or rule diversity within unity. Two is the archetype of diversity, but is subservient to and inferior to the archetype of unity. Therefore, the principle of diversity has half the power of the principle of unity, because it is a divided power. And in Pythagorean division, that which is divided loses according to the ratio of division. Therefore, division or diversity can never be equal in strength to unity. If it was equal or could be superior, it could destroy unity. But it can never destroy, because in a state of division, things can never have the strength of unity. And in order to achieve that strength of unity, they must annihilate their own diversity. And the moment they do so, they are unity. Therefore, the concept of the rebellion and the rebellious angels in the Pythagorean system, evil can never triumph over good. Because no matter how strong it can be, evil can never be more than one half the strength of good, because it arises from diversity. And is a result of never being equal to good. It can only equal unity by reconciling its own division. And if it reconciles its own division, it is no longer division, it is unity, and evil ceases. Evil, therefore, is division. And if a division is destroyed or removed, then unity alone remains. And this brings us to a very interesting phase of Pythagorean thought, which is the similitude and dissimilitude of number. All numbers in any level have a similitude to similar numbers in all other structures in the universe. Therefore, numerically, there is a similitude in the numerative soul between 11 elephants and 11 mice. The similitude lying in the number 11, which is a totality and a concept. This does not mean that they are identical, but 11 of anything will have the principle of 11 in common. Always, therefore, things are of their own similitudes. All unities, therefore, on any level, have a similitude to reality, to deity itself. All division on any level has a similitude to division in principle. And it is the rule of division that it can never have the same power that unity has. Diversity can never, therefore, overwhelm or overcome the principle of unity. One of the examples of that is that diversity is separated by the primary interval, which we said is intellect. That is the reason why you can have 500 different denominations of one religion. And while these denominations are measured by the interval of intellect, they'll never get together. They cannot unite while the interval remains. For this reason, Pythagoras said that two wrongs can never unite and become one wrong. Because the moment they united, they would be good. They would be God again. Therefore, two rascals can never have the same fraternity that two good people can have. It is impossible for diversity ever to win. It is impossible for corruption ever to win. For diversity, by principle, cannot unite with itself. Therefore, the thieves cannot get along together. And they found out in Cicero a number of years ago that if you just left the racketeers alone long enough, they'd kill each other and save the government considerable expense. Of course, they might get a few honest citizens in the interval, but ultimately, people who have those characteristics will outwit each other, will prey upon each other, will injure each other, and ultimately destroy each other. Therefore, no amount of wrong heaped together can ever become a unity. Therefore, it can never be a dynamic. It must always be a static. No matter how much wrong there is in the universe, it can never in substance equal one good. On the other hand, good, one, symbolizing truth, reality, wisdom, is compatible with unity everywhere. Two truths uniting become one truth. Two errors can never unite. Therefore, regardless of everything that happens, growth is the inevitable union of realities and the impossibility of the union of unrealities. Therefore, we may see what appears to be advantageous coalescences of despots. We may see dictators creating treaties, but these are not treaties of union, they are treaties of expedience. And if either of these men gets to a condition where he does not need the other, he will break the treaty. There is no integrity there. Wisdom also is forever building, and all that men learn that is true becomes part of one ever-increasing truth. We may make mistakes, we may have to do it over again. Sometimes we thought it was true and it wasn't. But if it is not true, it will fall away. It cannot survive. But whereas truths are always coalescing, so that the good man of any faith will ultimately be one with the good man of any other faith, because by their conduct, by their principles, by their codes, they have in common even what their words may deny. Realities build forever. Because realities are unities which unite to form unities, because each reality is a unity. But each unit of error is itself a diversity, or a duality. So all realities become or are by nature one. All error is by nature two. And it is interesting that Pythagoras in his thinking should assign the word science to the number 2, because he pointed out that science requires for its existence 2 dots in an interval, and without this it is immeasurable and unknowable, because science cannot function without comparison, without weighing things against each other, by a period or process of criticism, by the estimation of the action of phenomena upon phenomena. It can never arrive at a conclusion from a single monad. It must always use comparative powers for the determination of its findings. Therefore, it can extend itself over an area, and can make the interval between the two monads as great as it may conceive. But in order to exist as a science, the scientist must have two objects, at least, upon which to function. He must say, this is small because this is larger. He cannot determine the nature of size because he has only relativity. And the concept of estimation based upon two dots in an interval is properly termed relativity, because it depends for all conclusion and deduction upon the weighing or estimating of one thing by another. Whereas Pythagoras said unity is the estimation of thing by itself. Thus, unity represents intuitive or apperceptive comprehension of the unity of things, whereas all phenomenal knowledge depends upon duality. You can take an interval of two dots and you can place science on one end, philosophy on the other. Or you can take religion and science. Or you can come down to another level and you can say management and labor. You can come down to any level you want. You can then take all the articles or artifacts that are used in the maintenance of modern culture, government and the governed, credit, debit. You can go through every phase of a material culture and it subsists only because of two units and an interval. And therefore it belongs essentially to the sphere of diversity or duality. And because of that, these various activities can of themselves never coalesce. They can never unify, because they belong to a principle of diversity. And the only way in which they can be reconciled is by means of the numerative soul power in man, who alone can bind these things together. And to bind these things together, he must have the apperceptional power of the monad, which theoretically the Greeks would have called in the intelligible power of nature. In other words, the individual, to reconcile opposites of any kind, must attain a position of unity superior to the opposites which he wishes to reconcile. He must therefore, in qualitative interval, ascend above the duality. His own consciousness must be higher than division, or he can never reconcile divided parts. In every part of nature, therefore, in the moral life of man, the solution of a problem, and a problem is two dots in an interval, regardless of what the problem may be, because it is a problem perhaps of decision. Decision is two possible courses and their consequences, the interval. The only possible way of solving a problem of diversity is by obtaining an apex of unity above it. This means that we can never solve a problem of living on a level. Therefore, we can never solve a problem mathematically. The solution to problem is geometric, because we have to move into other dimensions. As long as we are mathematical, we are functioning on the level of the motion of numbers, and the motion of number is from one to diversity. The only way in which we can transcend or unify diversity is through ascending up the geometric ladder from the solid to the surface to the line to the point. He makes a very great deal of this. Of course, his thinking on it is much more complete than we have been able even to speculate this evening. All we can do is take a few symbolical points out of it, because it would take years. It took his own disciples 30 and 40 years to get the first principles. So we're not going to make it this evening. But we can suggest certain lines of speculation. Now in Plato we have the same thinking in a little more simple, familiar term, in the contrast between Plato and Aristotle. We have, for instance, Aristotle, who would walk into the city and try to understand it by counting the streets and the houses. And he would gradually come to a conclusion, and he would finally make you a drawing of the city. And the drawing of the city would be comparatively accurate. But it is very possible, as the old saying goes, which is, most of you know, that he would never see the city for the houses. He would become constantly more and more immersed in the details of the city. And probably somewhere along the line he would find something so devastatingly interesting in the city that he would stay there for the rest of his life. Plato, on the other hand, assumed that the proper course for man is to first climb a mountain and look down on the city. And having first seen the city as a totality, then to descend into the city, bearing always in his mind the total picture, then explore the streets and become immersed in the details. He could then do it safely because he had already a vision of the city which he could not lose. And therefore the city from that time on had a meaningful topography for him, far greater than it could possibly have been had he begun to examine first the streets. So that in this sense of the word, the man who climbs up onto the mountain takes the position of the one dot at the top of the pyramid. He stands there and looks in all directions, including downward. He sees the entire pattern of the unfoldment of the order of both numeration and number. He may then go downward into the city, and he may take science, or he may take art, or he may take music, and he may become greatly involved in these little dots and the intervals between them. But he still has within his consciousness the recognition of the archetype of totality. He has seen the whole picture. He has seen the city. Therefore, he is not going to lose sight of the city and become hopelessly bogged down in some detail. Now, he may assume, Aristotle probably did assume, that no individual could master all of this tremendous picture. Therefore, he could spend his life studying one of the intervals between two dots, and that would be the most he could hope to accomplish. Here, however, Pythagoras would have corrected him on this point, that regardless of whether he knows it or not, he will never be able to understand the interval between two dots until he understands the whole picture. Therefore, his study of any particular thing inevitably depends for its accuracy, for its fertility, for its reality, upon the total concept. Therefore, the study of diversity without an apperception of unity will lead to materialism. Because this means the exaggeration of the significance of parts above that totality. The individual who spends all his life digging up Abyssinian or Babylonian rolls is quite certain that history began and ended in Babylonia, and that the most valuable of all possible activities is turning the soil and finding these little cylinders with the name of some ancient king carefully carved into the surface. When he finds one of them, he is happier than the Texas oil magnate who has discovered 10 new oil wells. This little cylinder becomes his life. Now he becomes what might be termed an authority on the subject. But being an authority on it, he is still completely uninformed on the essential reason not only for life, but for those little rolls that he himself is handling. He will never understand the Assyrians or the Chaldeans or the Arcadians until he understands their relation to the various intervals which make up the complete field and are enclosed within totality. He will never realize the lesson of a civilization until he is aware of the grand motion of civilizations. He will never have any true elevation of himself as being. He will never gain the experience of unity in these things, which is necessary to make them meaningful, if he remains hopelessly immersed in the diversity. Therefore, the number 2 not only becomes the number of science, but it becomes the number of specialization. It becomes the number of all involvement, by which man enters into a competitive relationship with himself, with others, or with knowledge. And the understanding of this and the correction of the interval through the re-establishment of the total concept of unity is the rescuing of the monadal power of the archetype, or it is what we've called the numerative soul, or the soul which orders things and reduces all numbers to their part in unity. A very large and important concept. Now, it takes much more time sometimes to talk about these things, and it's much less profitable than the experiences which the individual himself has. And each person, whether he knows it or not, frequently establishes unity without knowing that he is doing so, because he is instinctively following the habit of the numerative soul within himself. So Pythagoras pointed out one other point that is very valuable, namely, that unity is something which is natural to things. Diversity is something that is artificial to things. Unity represents the eternal state of the divine nature. God, in order to create, had to perform a separate and distinct action. Therefore, this action was artificial to the nature of deity itself. And a man, in his contemplation of existence, is naturally good, but must create evil. Everywhere in the universe, unity is a natural thing unless it is artificially prevented from existing or manifesting. Men must therefore dynamically misunderstand in order to have difficulty. And so-called misunderstanding is simply lack of understanding, and lack of understanding is lack of unity, or lack of the unitive power in consciousness. Therefore, diversity is an artificial condition, which is not permanent nor real, but only apparent. Whereas unity is a natural and eternal condition, real though not apparent. But through the philosophical study of numbers, the reality of unity can be mathematically demonstrated, and the unreality of diversity can be mathematically demonstrated, and in this way appeal to certain minds so constituted that they are naturally inclined to accept upon this level. Now there's more to be said. We'll have to say it next week.